So we are back here again with one more new video on the solid state chemistry. In the yesterday's lecture we had learned about the unit cells, crystal lattice and the lattice points and the 7 crystal systems. Today we are going to talk about the 14 crystal systems and the total number of atoms present in that crystal systems, right? So it is going to be a very informative lecture. So let's come today here on the board. Types of unit cells. Types of unit cells, right? So what is a unit cell? Unit cell you all know. We have seen yesterday. So we draw this simple cubic. If we divide this crystal into a small parts, the smallest part of the crystal which is obtained is said to be the unit cell, right? So you understood what is the unit cell now. Today we will see the type of a unit cell, and based on this type of a unit cell we are going to classify the 14 crystal systems, right? So let's see one by one. Number 1, simple or primitive unit cell. Simple or primitive unit cell. Now word itself tells you that it is a very basic unit cell or a primitive unit cell. Now how we can draw this simple unit cell? See, try to understand, my dear students, this is all 3-dimensional structures, right? So here in this case of a simple unit cell, all the particles are there present at the corners. See, all the constituent particles are there at the corners. That is why it is said to be a simple or a primitive unit cell. There is no presence of any other particle at the face or at the center of the body, right? So they are called as the simple or a primitive unit cell. Then second type, centered unit cell. Centered unit cell. Now under this centered unit cell, number 1, face centered unit cell. In this face centered, let's draw the face centered. Right? All the constituent particles will be present at the 8 corners. So there are 8 constituent particles. See, it is the basic constituent particles at the corners for all the cells will be same. That is the 8 constituent particles. It will be same for simple, it will be same for face, it will be same for the body centered also. Right? So in this case, now what is the difference between the face and the simple one? Here in this case there is no constituent particle present at the face, but here there will be a constituent particle present at the face. Now I can show you on the faces. See, this is one face, this is one face, this is one face, this is one face, right? So 1, 2, 3, 4. How many number of faces are there? There are total 6 faces. Take the example of this room. This room has a one face here, one face here, one face here, one face this side, one face up, one face down side, right? So total number of faces are 6 faces are present, right? So 1, 2, 3, 4, one at the bottom, one at the top side. I hope that you have understood now that there are total number of 6 faces are present in the system. Okay, now next one is the body centered. Body centered. Now the word itself tells you that this particular unit cell is at the center of the body. Again we will draw the basic structure. All the constituent particles will be present at the corners. So at total 8 corners, 1, 2, 3, 4, 5, 6, 7, 8. So here there will be 8 constituent particles again. Now what is the difference? The difference here is you can see that one particle is present in the center of the body, right? The particle is present at the center of the body. That is why it is said to be a body centered unit cell, right? Then next we have end centered unit cell. Third one, end-centered unit cell. Right? So in the end-centered unit cell, we will draw this once again. Again, there will be 8 constituent particles at the 8 corners. See, 1, 2, 3, 4, 5, 6, 7, 8. Right? Now what happens in the end-centered? In the end-centered, we will see that at the 2 ends, there will be a presence of a particle. Right? So this is said to be the end-centered. At this one top end, at this one bottom end. Right? I hope that you might have understood this. Then there is one more. That is said to be the edge-centered. Edge-centered. Note it down. Edge-centered unit cell. Right? So what happens in the edge-centered unit cell? We will draw the structure once again. Again, the constituent particles are at the 8 corners. Right? The constituent particles are there at the 8 corners, and between the center of every edge, you will see that there is a particle present. So this is said to be the edge-centered unit cell. Right? I hope that you all might have understood the types of a unit cell. So what are the type of a unit cells? Simple or primitive unit cell, centered unit cell. Under the centered unit cell, there are body-centered, there are face-centered, there are end-centered, and there are edge-centered unit cell. Right? So these are the type of a unit cell. I request all the students to note down this. This is very, very important. Then let's move for the next point. Now based on this types of a unit cell, we are going to classify the 14 crystal system. This is very, very important. 14 crystal system. Let's understand. I request all the students to note down this 14 crystal system. This is very, very important. 14 crystal system. Right? So let's draw one table, and with the table you can understand how the types of crystals are there. Types of a crystal. Then here we have the body, a simple or a primitive unit cell, then face centered, then body centered, and then last end centered. Right? So let's see in which crystal which particular unit cells are present. Now first we will begin with the cubic. We'll write down all the 7 crystals. Cubic, tetragonal, orthorhombic, monoclinic, then hexagonal, rhombohedral, and triclinic. Right? So this is what we have learned yesterday. Types of a crystal: cubic, tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral, triclinic. So let's understand what are the other kinds of a unit cell which are present in the cubic. Right? So for the simple and primitive, simple, every crystal will have a simple unit cell. All will have a simple unit cell. Right? That means all 7 are containing the simple unit cell. Then talking about the cubic, face centered, it has a face centered, it has the body centered also, but it does not contain the end centered. Talking about the tetragonal has the body centered, it does not contain the face centered, it does not contain the end centered. Talking about the orthorhombic contains the all 4: face centered, body centered, end centered, and simple. Talking about the monoclinic contains the simple as well as the end centered. Right? And talking about the hexagonal, rhombohedral, and triclinic, they all are containing only simple unit cell or a simple crystal, right? So I hope that this becomes your 14 crystal system. Let's understand the 14 crystal system. Number 1, simple cubic. Number 2, simple tetragonal. Number 3, simple orthorhombic, simple monoclinic, simple hexagonal, simple rhombohedral, simple triclinic. So this becomes your 7. Then face centered cubic, face centered orthorhombic. This becomes your 9. Then body centered cubic, body centered tetragonal, body centered orthorhombic. This becomes your 12. Then end centered orthorhombic, end centered monoclinic. So 12 plus 2, that is equals to 14. So this is our 14 crystal systems. I hope that you might have understood this 14 crystal systems. Okay, now let me tell you one more thing. The angles. Yesterday we had also seen in a 7 crystal systems that there is a presence of some kind of a edge length and some kind of an angle is present, right? So here in this case, let's take the example of a cubic. Cubic has an angle of A equals to B equals to C, edge length. And angle of alpha equals to beta equals to gamma equals to 90 degree, right? So this is what is the angle and the edge length which is present in the cubic. So for the simple cubic, the edge length will be A equals to B equals to C. It will be same for the face centered. It will be same for the body centered, right? And the same angles will exist for the simple, for the face and for the body centered. So I hope that you might have understood. Similarly applies for the tetragonal, orthorhombic, monoclinic, hexagonal, rhombohedral and the triclinic. All the angles and all the edge lengths. I hope that you might have understood the concept of this 14 crystal systems. I request all the students to note down this 14 crystal systems. Right? Okay, talking about the next topic. Next topic is also very important topic. That is calculation of the total number of atoms. Calculation of total number of atoms. You can note it down. Total number of atoms in the unit cell. In the unit cells. Right? So here we will take first example of a simple unit cell. Right? Simple unit cell. Simple unit cell is also called as the primitive unit cell. So in this case, we will find out the total number of atoms which are present. So let's draw the simple unit cell. So this is our simple unit cell. You all know that every unit cell contains the 8 constituent particles at the corners. So let's draw this 8 constituent particles. Right? As there is no presence of a particle in the center or at the faces, so here there will be only 8 particles at the corners. There will be no face centered particle or there will be no body centered particle. So how many number of particles are there? 1, 2, 3, 4, 5, 6, 7, 8. Only 8 particles at the corners. Now always remember one simple rule, that whenever the particles or whenever the atom is arranged at the corner, in order to find out the total number of atoms, we need to multiply by 1 by 8. Now why 1 by 8? Because let's take an example of this atom. Right? Atom is a sphere. Now this sphere is shared by the 8 unit cells. Right? One particular atom is shared by the 8 unit cells. That is why it becomes 1 by 8 portion of it. So let's say that this particular part may be 1 by 8. This is 1 by 8. This is 1 by 8. This is shared by 1 by 8. This is 1 by 8. This is also 1 by 8. This is also 1 by 8 and this is also 1 by 8. Are you understanding it? See, this is the particle which is present at the corner. So one particular atom is shared by the 8 unit cell. So each of them will be getting the portion of 1 by 8. Right? Now total number of constituent particles at the corner. At the corners, the constituent particles are 1, 2, 3, 4, 5, 6, 7, 8. So 8 atoms at the corners into one particle is shared by the 8 unit cells, that is why 1 by 8. So the total number of atoms present in it will be 1 atom. Are you understanding it? So 1 atom is present in the particular unit cell. Now let's take an example in a very simple lucid language. Let's say that we have one Cadbury chocolate, right? You have one Cadbury chocolate and it has 8 cubes. 1, 2, 3, 4, 5, 6, 7 and 8 cubes it is having, right? So in this 8 cubes and you have 8 friends. 8 friends you have. So what will be the division? So everyone will get the 1 by 8 portion, right? So everyone is going to get one piece. Suppose you are there to divide this. When you give away all these 7 cubes, what is remaining with you? Only 1 cube is remaining with you, right? So similar here also it applies. There are total number of 8 constituent particles, but one particular is shared by the 8 unit cell. That is why it becomes the 1 by 8 into 8. The total number of atoms will be 1 atom, right? I hope that this might have understood to you, right? Okay, let's move further. Now calculate the total number of atoms. Give the heading total number of atoms present in the face centered cubic cell. Total number of atoms present in FCC lattice. So you all know what is the FCC lattice, right? We'll draw this FCC lattice. See, again 8 constituent particles at the 8 corners, and then I'll draw it with the other pen. 1, 2, 3, 4. At the back side one more particle is there, and at the bottom side there is one more particle is present, right? So here there are total number of how many faces? 6 faces are there, right? So let's say if I divide this particular crystal into 2 halves. So you can clearly see here this particular particle which is present at the face is getting divided into 1 by 2 and 1 by 2 part, right? So how we can write? We can say that at corners, you know what is the situation at the corners. At corners we have 8 particles, so that will be 1 by 8 into 8 is equals to 1 atom. That is what we have seen in the simple unit cell, right? 1 by 8 into 8 is equals to 1 atom. That is the situation for the atoms which are present at the corners. Now we will talk about the atoms which are present at the face. Now at the face, what is the situation at the face? It is divided into 1 by 2 portion now. 1 by 2 into how many number of faces are there? There are total 6 faces. So it becomes 3 atoms. Now the total number of atoms will be 1 plus 3 is equals to 4 atoms. I hope that you all might have understood the concept of this particular FCC lattice. How many number of atoms are present? 4 atoms are present. Let's move further. Let's take the next example. That will be of BCC lattice. So this will be of BCC lattice. In the BCC lattice, let's draw the structure of a BCC lattice. So the particle here, 8 constituent particles at the 8 corners, and 1 particle is present in the middle, right? In the middle of the body. Now let me tell you, this particular particle is not sharing its part. It's not sharing its part with anyone. So this body centered particle will be count as one atom. This body centered particle will be count as the one atom. And as we all know, what is the situation at the corners? At the corners, the situation is 1 by 8 into 8, that is equals to 1 atom. So 1 plus 1 is equals to 2 atoms. I hope that you all might have understood the concept of this total number of atoms in the unit cells. Now why this is important? This is important because further we are going to do the calculation for the density of the unit cell. At the calculation of the density of the unit cell, we will be requiring the total number of atoms present in the unit cell. That will depend upon the whether it is simple. Simple will contain the total number of atoms 1. Then face centered will contain 4 and body centered will contain 2 atoms. Right? So my dear students, you might have understood this. So that is enough for the day. Tomorrow we will come with one more new lecture, that is the packing of the solids. Thank you very much.